Very good morning, students, and welcome to the digital classroom of General Science. Dear students, we have finished with lesson number 12 workbook exercise last time, and today we are going to start with a new lesson, chemical change and chemical bond. Now, students, today is your last science lecture before Diwali vacations, and in this lecture we will be able to complete the explanation of this lesson number 13, and I will be sending the workbook exercise PDF in your class WhatsApp group, which you can complete during the Diwali vacation. Okay students, so please do not forget to complete the workbook exercise of this lesson number 13 during Diwali vacation. Now let's start with the lesson chemical change and chemical bond. The physical change and the chemical change. And we had studied that in a chemical change, the new substance are formed which has a different taste, appearance, color, taste, all these things change. And this happens because the chemical composition of the original substance changes and a new substance is formed. So in this lesson, we are going to study how we can identify whether a chemical change has taken place. So you can see in the picture, there is a glass in which a liquid is overflowing in the form of foam or bubbles. Now, for this, if we perform the experiment, we have to take a glass and in it we have to take the lemon juice, okay, and then we have to taste the lemon juice. It is very sour, okay. Now, when we add a pinch of baking soda or khane ka soda, which we use in our day-to-day kitchen, we see that as soon as this baking soda is added in the lemon juice, it starts bubbling. The gushing sound can be heard and the foam is formed which comes out of the glass. We can hear a sound also. Now if we taste this, the taste of this new product is changed, right? Now, when we had added baking soda in this, we saw the gas liberating out in the form of the bubbles. And the taste of the lemon juice also changed. It became little mild. It was not that sour, or completely the sourness of the new product is vanished. So we can understand there is something new formed which is having a different taste, right? Because the chemical composition of the substance has changed and a new substance is formed. So such a change is called as a chemical change. Now in the pictures you can see the different types of the chemical changes taking place. In the first picture we can see the apple. If it's cut and it is kept open, it turns reddish brown, right? The taste also changes, the color also changes. Second, if we keep a piece of bread open for few days, we will see that a yellowish green color fungus develops on the bread. If we keep the nails open, they come in contact with the vapors in the air and oxygen, and thus they turn reddish brown or they get rusted. Banana is kept for 2 to 3 days. It turns blackish in color. The texture also becomes soft. The taste also changes. If I keep a liquid for few days, the color of it changes. So these are all the different chemical changes in which the chemical composition of the substance changes a new substance is formed, and the color can change, the texture can change, the taste can change, the appearance can change, because in chemical change a totally new substance is formed. Next we have to study about the chemical change and word equation. How to write or how to show the chemical change. Now, during a chemical change, the chemical composition of the original matter changes and new substances which have different properties and different chemical composition are formed. Now, a chemical equation can be written for a chemical change. That is, chemical change can be represented with the help of a chemical equation. So, we can write using a chemical equation like in the following picture. When baking soda is added to lemon juice, a chemical change takes place and the lemon juice taste changes and the gas is formed. Now this gas is carbon dioxide. So how can we write this chemical change in the word equation? Now the lemon juice contains citric acid. When we add baking soda, that is sodium bicarbonate, carbon dioxide gas is given out and sodium citrate salt is formed. Now this also we had studied in the previous lesson in the form of the neutralization reaction. When an acid and base react, they form salt, right? So this is the chemical change. Citric acid reacts with sodium bicarbonate, carbon dioxide is given out and sodium citrate is formed. Now, when we write a chemical reaction or a chemical equation, first we have to write the names of the substances which take part in the chemical change. So, on the left hand side, we have to write the raw substances or the substances which are reacting with each other, and they are called as the reactants. Okay. And then we have to show an arrow which represents that these reactants, these original substances change into a new product, new substance, and these are called as the products, and they are written on the left hand side of the reaction. Okay, so the reactants are written on the right hand side and products are written on the left hand side. The reactants are the substances in which the change takes place, and products are the substances which are formed after the chemical change has taken place. So reactants, they convert into the products, and this is written in the form of a chemical equation. Then we will study about the different chemical changes which take place in our day-to-day life. First we will study about the natural chemical changes, and then we will study about the man-made chemical changes. So first let's start with the natural chemical changes. Respiration, a very simple process. We had studied that we take in oxygen and we give out carbon dioxide, and inside the cells the cellular respiration takes place, in which the food is oxidized and it forms carbon dioxide and water. So the food which is eaten is in the form of the glucose, that is C6H12O6. It comes in contact with the oxygen. So this glucose and oxygen, they react and they form carbon dioxide and water. So the word equation is glucose plus oxygen, arrow carbon dioxide plus water. This chemical equation represents the process of respiration. And the chemical reaction is C6H12O6 plus O2. During respiration, it forms CO2 and H2O. Second, our day-to-day example is photosynthesis. Photo means light and synthesis means to manufacture or to make. That is, the plants in the presence of sunlight synthesize the food with the help of chlorophyll, carbon dioxide and water. So, this process is called as photosynthesis. Now, if we have to write the photosynthesis in word equation, we will write carbon dioxide plus water, arrow glucose plus oxygen. Because glucose is formed, food is formed during photosynthesis and oxygen is released, right? Now, photosynthesis is just reverse the respiration, because in respiration we take in oxygen and give out carbon dioxide. In photosynthesis, the plants, they take in carbon dioxide and they give out oxygen. So the process of photosynthesis, if we have to write in the chemical equation form, it will be written as CO2 plus H2O, arrow C6H12O6, that is glucose, plus oxygen. So carbon dioxide and H2O are the reactants and glucose and oxygen are the products. Then we will study about the man-made chemical changes. Now these are the chemical changes, respiration and photosynthesis, which naturally take place. But certain chemical changes are brought about by human beings, right? So we will study about these man-made chemical changes. And the very first one we are going to study is combustion of fuels. Now, wood, coal, cooking gas, petrol, diesel, they are burned for getting the energy, right? Now, the common substance that is present in all these fuels is carbon. Now, when the combustion process takes place, that is, the carbon present in the fuels, it combines with the oxygen and forms carbon dioxide. So if we write the word equation of this, it is carbon plus oxygen, arrow carbon dioxide. And if we write the equation form of this, it is C plus O2, arrow CO2. C and O2, they are the reactants and CO2 is the product. Okay, so this is a chemical change. Now these chemical changes are quite fast and they are irreversible. We had studied in the previous lesson, the chemical changes are irreversible. The new products which are formed, they cannot be converted back into the original substances because their chemical composition changes, right? So, combustion of fuel is a fast and irreversible chemical change. The next man-made chemical change we are going to study is cleaning the Shahabad tile with dilute hydrochloric acid. The Shahabad tile is nothing but the marble stone which we call, that is the Shahabad tile, and it is calcium carbonate. The chemical name of Shahabad stone is calcium carbonate. Now, if we clean the calcium carbonate or the marble tile with hydrochloric acid, then we will see that new products are formed which are calcium chloride, carbon dioxide and water. Now here we will see that the air comes out in the form of the bubbles and carbon dioxide is formed. Okay, so this word equation of this can be written as calcium carbonate plus hydrochloric acid arrow calcium chloride plus carbon dioxide plus water. And if we write the equation form, it will be CaCO3, that is calcium chloride, plus hydrochloric acid gives calcium chloride plus carbon dioxide plus water. This is the chemical equation of cleaning Shahabad tile with dilute hydrochloric acid. Okay. The third one is given as softening of hard water. Now, the water which we get from the tube wells or wells, it is hard water. The taste is different and it does not form lather with the soap, because this hard water contains the salts of calcium and sulfate of magnesium also in it, right? So it is magnesium chloride, magnesium sulfate, calcium chloride and calcium sulfate. Now we have to soften this hard water, and it is done by adding sodium carbonate, right? Now when we add sodium carbonate, we get the precipitate of carbonate salts and the water becomes soft. Now, if we have to write this word equation, we will write calcium chloride plus sodium carbonate. It gives calcium carbonate plus sodium chloride. And if we have to write the equation form of softening of hard water, it is CaCl2 plus Na2CO3 arrow calcium carbonate, that is CaCO3 plus NaCl sodium chloride. So, this is the equation form of the softening of hard water. Now we will study about the chemical bond. In the lesson inside the atom, lesson number 5, we had studied about the electronic configuration and valency of the element. And we had studied about the valency electrons which are present in the outermost orbit of the atom. In the same lesson, we had also studied that the noble gases, they do not form any chemical bond. Why? Because their outermost orbit is complete. Either it is duplet or it is an octet. That is, either it has 2 electrons in the outermost orbit or it has 8 electrons in the outermost orbit. And we know that if the electrons are less than 8, then these electrons, they form a chemical bond, right? And the chemical bonds is equal to the valency of the atom. Now we will start with the ionic bond. Now the chemical bonds are of 2 types. First is ionic bond and the second one is covalent bond. You can just see the picture on the screen, the ionic bond and covalent bond. I will just explain it to you. What is the difference between the ionic bond and the covalent bond? Now first we will start with the ionic bond. Now in ionic bond, first we will see how the compound sodium chloride is formed. Sodium chloride is formed of 2 elements, sodium and chlorine. Sodium atomic number is 11. That means atomic number is equal to number of protons or number of electrons. So 11, if we do the electronic configuration, it comes to 2, 8 and 1. That is, in the last orbit only 1 electron is present in sodium. Whereas the atomic number of chlorine is 17, that is number of electrons is 17, and if we write the electronic configuration, it comes to 2, 8 and 7. Now in sodium, the third orbit is having just one electron, that is the outermost orbit is incomplete, and in chlorine, in the last orbit, the 7 electrons are there. So it needs one more electron to complete the outermost orbit and obtain a duplet, right? Now see in the picture, sodium is having 11 electrons. In the first picture you can see the 2 electrons are there. In the second one 8 electrons are there, okay, and in the third one only 1 electron is there. Whereas if we see the chlorine, in the first orbit 2 electrons are there, in the second orbit 8 electrons are there, and in the third orbit 7 electrons are there. Now when this sodium and chlorine they react with each other, one electron of the outermost orbit of sodium is donated to chlorine, right? Now we know that the number of protons and number of electrons in an atom are same, and thus as the positive and the negative charges are equal, they nullify each other and the atom does not have any charge. But now sodium has donated 1 electron to chlorine. So in sodium the number of protons is 11, whereas the number of electron has become 10. Okay. So one positive charge is more. So as it donates 1 electron to chlorine, it forms sodium plus 1 ion, right? In chlorine, it was having 7 electrons in the outermost orbit. Now it has accepted the 1 electron donated by sodium, and now it has 2, 8 and 8. That is, now it is having 18 electrons but 17 protons, right? So 1 proton is less, 1 electron is extra. Thus this chlorine atom converts into chlorine minus 1 because it has 1 extra electron. This is how the sodium chloride is formed. So sodium and chlorine atom, they are converted into sodium and chlorine ion. Now as we know that there is always an attraction between the positive and negative. So this attraction is called as electrostatic force of attraction between the positive sodium ion and negative chlorine ion. So they form a bond with the help of these electrostatic force of attraction, and these two, positive ion and negative ion, they come together and they form an ionic bond or an electrovalent bond. Okay, so this is how the ionic bonds are formed. So the ionic bond of sodium ion and chlorine ion is formed, and it forms a new compound, that is sodium chloride. Then the second example we are going to study of the formation of new chemical bond is magnesium chloride. How the magnesium chloride molecule is formed due to the electrostatic force of attraction between the positive and the negative ion. Magnesium atomic number 12 and electronic distribution is 282. It has 2 electrons in the outermost orbit. Chlorine atomic number 17. It has 7 electrons in the outermost orbit. And when these two atoms, they come near each other, they tend to complete the outermost orbit of their orbit with 8 electrons. So this magnesium, it gives away 2 electrons to 2 different chlorine atoms. Now when it donates these 2 electrons, it gets plus 2 charge because 2 protons have become extra, right? Because it has donated 2 electrons. Whereas each chlorine atom converts into chlorine minus 1 ion because each chlorine atom has received 1 electron. That means it has received 1 negative charge, and thus the new substance, the new compound MgCl2 is formed. This is how the new ionic bond between magnesium and chlorine is formed, and the new compound magnesium chloride is formed. Next we are going to study is the covalent bond. Now, covalent bond is formed when the atoms of two elements, they come together and they share the electrons. The difference between the ionic bond and covalent bond is, in ionic bond, one atom donates the electrons and the other atom accepts the electron. But here in covalent bond, the electrons are placed in the center and both the atoms, they use these electrons, they share these electrons and they complete their outermost orbit, right? Now, if we see the formation of hydrogen molecule, we know that hydrogen has only one electron in the outermost orbit. So, these two atoms, they come near each other and they keep their one single electron in the center, and they both use these two electrons to complete their duplet, and thus they form the hydrogen molecule, right? So the bond formed by sharing of valency electrons of two atoms with each other is called a covalent bond. One covalent bond is formed by sharing of two valency electrons. So this is how the hydrogen molecule is formed. So the chemical bond formed by sharing of valency electrons of two atoms with each other is called as a covalent bond. We will see one more example of covalent bond where the hydrogen and oxygen, they combine and they form a molecule of water. Now water molecule is H2O, that means two atoms of hydrogen and one atom of oxygen. Now oxygen has atomic number 8. So its electronic configuration comes to 2 and 6. It has 2 electrons in the first orbit and 6 electrons in the outermost orbit. Hydrogen has just 1 electron which is present in the orbit. Now oxygen needs 2 more electrons to complete its octet, whereas hydrogen, they need 1 more electron to complete their duplet. So oxygen keeps it 1 electron in the center with 1 hydrogen atom and the other 1 electron with the other hydrogen atom. And hydrogen atom also keeps its 1 electron in the center, as the second hydrogen atom also keeps its 1 single electron in the center. And then in the outermost orbit of the oxygen becomes 8, 6 of its own, 1 from first hydrogen atom, 1 from second hydrogen atom, and the octet is completed. Similarly, hydrogen also shares 1 electron from the oxygen outermost orbit and completes its duplet. Similarly, the other hydrogen atom also takes 1 electron in the center and completes its duplet and thus forms 1 molecule of water or H2O. And this is how the covalent bond is formed. It is actually not given in the textbook, but just for your information, when you will go to the higher classes, when one pair of electron is shared between the atoms, it is called as single covalent bond. If two pairs are shared, it is called as double covalent bond. And if three pairs of electrons are shared, then it is called as triple covalent bond. This we finish with the lesson, students, and I hope that in the next period you will be ready with the workbook exercise. So we will meet in the next science lecture and we will discuss about the workbook exercise of this lesson. Till then, take care, students. Thank you.